is usually a problem on the CUNY assessment test involving percent increase or percent decrease. Percent increase and decrease problems. Okay, and the best way to study these is simply to try examples. Here's a typical one. A man earns $15,000 a year. He is given a 6% salary increase. What will be his new salary? Man earns $15,000 a year. He is given a 6% salary increase. What will be his new salary? Okay, his new salary is, of course, equal to the old salary plus the increase. The increase is 6% of his salary. So we will multiply. Okay, the increase is 6% of his salary. So the increase is equal to his salary, $15,000, multiplied by 6%, or 6/100, or 0.06 for the corresponding decimal. We will compute 6% of 15,000, 6/100, or 0.06 times 15,000. Okay? You can do this either as decimal multiplication, or you could say 6/100 times 15,000. Dividing numerator and denominator by 100. You can cancel off 2 zeros there. And you get 6 times 150, or 6 times 0. 6 times 5 is 30. Carry the 3. 6 and 3, 9. So his increase is $900. 6% of $15,000 comes out to be $900. Okay, the answer to the problem, however, is not $900. The new salary is the old salary, which was $15,000, plus the increase, which we have computed to be $900. So his new salary, and the correct answer to this problem, is $15,900. There is a way of doing this problem sort of in one step. Let's see what we had. We had that the new salary, which is what we were looking for, is equal to the old salary plus the increase. The old salary was the $15,000. And the increase was 6%, or 0.06, of the old salary. So the correct answer, the salary is $15,000 plus 6% of the $15,000. Now, we can factor out a 15,000 here and use the distributive law. 15,000, this is like A times B plus A times C is A times B plus C. This would leave us to the left of the plus sign with a 1, and to the right of the plus sign with a 0.06. Let's see if that works out. If we have A times B plus C, the distributive law tells us it's A times B plus A times C. 15,000 times 1 plus 0.06 should be 15,000 times 1, which is correct, plus 15,000 times 0.06. Okay, so this can be thought of as 15,000 times 1 plus 0.06, or 15,000 times 1.06. You might think of this as 106% of his original salary. His new salary is really 106% of his old salary. In other words, it's his entire old salary, which was 100% of his old salary, plus the increase, which is another 6%. So he'll be making 106% of his old salary. 106 divided by 100, if you want to change it into a decimal, a fraction. 106 divided by 100, which of course is 1.06. So 106% of his old salary, or 1.06 times his old salary. And if you wanted to do it, you could do it in this form. And you would have 15,000 times 1.06. I'm not saying it's easier, but I just want to point it out as a possibility. 6 times 15,000, so 0, 0, 0. 6 times 5 is 30. Put down the 0, carry the 3, 3 and 6, 9. And then 0, so we'll need like a row of zeros here. And then indent one more time for the 15,000. 0, 0, 0, 5, 1. 0, 0, 0, 0, 9, 5, 1. Now, originally, we had no decimal digits here, 2 decimal digits here. So in the answer, there are 2 decimal digits, and we get 15,900, or 15,900 as his new salary. So it can be done piecemeal. Okay, take his old salary and then work out the increase separately. Or you can simply say, I'm looking for 106% of his new salary, 1.06 times his new salary, 15,900. For our next example, we have the following. A woman buys a book for $12.75. If the sales tax is 8%, how much money does she have to pay the cashier? A woman buys a book for $12.75. If the sales tax is 8%, how much money does she have to pay the cashier? If you think you can do this problem on your own, feel free to try it. You can shut off the machine and turn me back on when you think you have the answer. Okay. The total cost that you'll pay the cashier will be the cost of the book plus the sales tax. The cost of the book is $12.75, plus the sales tax. She'll have to pay an additional 8% of the cost of the book, so 0.08, 8%, 8 over 100, or 0.08. So this is 12.75 times 1 plus 0.08. Plus 12.75 times 1 plus 12.75 times 0.08. So 12.75 times 1.08. In other words, she has to pay 108% of the price of the book. 100% for the price of the book and the other 8%. Okay? Or you could work out the sales tax separately at the 0.08 times 12.75 and add it to the 1275. Okay, if we do it this way, 1275 times 108, 5 times 8 is 40, 7 times 8, 56, and 4, 60. Carry the 6, 2 times 8, 16, and 6, 22, 2 and 8, that's 10. Okay, next multiply by zeros. And then indenting one more time, multiply by the 1. 5, 7, 2, 1, 0, 0, 7, 7, 3, 1. Okay, now we had, this was 12.75 times 1.08. We had 2 decimal digits in the first factor, 2 decimal digits in the second, so there are 4 decimal digits. Adding them up, 2 plus 2, 4 decimal digits in the answer. So the answer would be 13.77, or if you think of these in terms of dollars, $13.77 is what she has to pay the cashier. Okay, let's try for our next example the following. A restaurant decides to increase all of its prices by 5%. If a roast beef dinner used to cost $17, what is the new price for that meal? A restaurant has decided to increase all of its prices by 5%. A roast beef dinner used to cost $17. It's now going to be 5% more. Okay, we want to find the new price of a roast beef dinner. Okay, so we want, the new price will be 105% of the old price, or 1.05 times the old price. You can just figure out the 5% of the 17 and add it on to the $17, or calculate 1.05, 105% of $17. Okay, 7 times 5 would be 35. Here we get 735. And here 1 times 105 gives us 105. Don't forget to indent. 5, 8, 17. 2 decimal digits here, none here, so 2 here. And the cost of the roast beef dinner will now be $17.85. Okay, now so far all of the problems dealt with percent increase. Now let's look at a problem that involves a percent decrease. We have the following. At a sale, all jackets are reduced by 30%. What is the sale price of a jacket which was originally sold for $75. At a sale, all jackets are reduced by 30%. What is the sale price of a jacket which was originally sold for $75? Okay, now the price reduction will be 30% of the original price, $75. Okay, the price reduction or the decrease in price will be 30%, $75. Okay, 75 times 0.30, 0, 3 5s, 15, 3 7s, 21, 22. 2 decimal digits in the answer. The price reduction is $22.50. Okay, so what is the sale price? The sale price of the jacket will be the original price, take away the price reduction. The original price, of course, was $75. Take away the price reduction of $22.50. $75 take away $22.50. We get 0. 10 take away 5 is 5. This is now a 4. 4 take away 2. 7 take away 2. So the sale price will be $52.50. We figured out 30% of the price of the jacket, $22.50. That's how much is being taken off the original price. $75 take away $22.50 leaves us with a price of $52.50 for the jacket. Now there's actually a more compact way of doing the same problem. If we think of it, the sale price is the original price minus the price reduction. The original price was $75. Take away the price reduction, which was 30% of $75. We can factor out the $75, and that will leave us with 1 minus 0.30, in much the same way that we did the other problems with the increase in salary. Let's check it by the distributive law. 75 times 1 is 75 minus 75 times 0.30. Okay, now that's $75. 1 take away 0.30 will be 0.70, 0.7. And we can directly calculate, in other words, the sale price is simply, since we have a 30% reduction, it is 70% of the original price. Okay, you can work it out separately, figure out 30% of the original price, and then subtract that from 75, but in this case it's certainly more difficult. Whereas here all we have to do is to multiply 75 times the 0.70, we get 0. 5 times 7 is 35, carry the 3, 7 times 7, 49, and 3, 52. 2 decimal digits in the answer, and we automatically get out that the sale price is $52.50. The subtraction is automatically done for you. We have done it in one step here. Okay, just like if you get a 6% increase in salary, your new salary is 106% of your old salary, or 1.06 of your old salary. If you get a 30% decrease in the price of a jacket, your new jacket price is 70% of your old jacket price. So 0.70, okay, times the old price, $52.50. For our last problem on this tape, we have the following. a man whose net income is $25,000 a year decides to begin a pension plan. He wants to reduce his salary by 5% and to have the money applied to his pension. How much money will he be taking home after the salary reduction? Okay, he's bringing home $25,000 a year, and he decides to begin a pension plan. He wants to reduce his salary by 5% and have that money directly deposited to a pension plan. How much money will he be taking home after the salary reduction? Well, you can figure out what 5% of his salary is, and that would be how much he's applying to the pension. You would then have to subtract that from the $25,000 a year that he's bringing home. Or you can simply say that if he is cutting his salary by 5%, he is bringing home 95% of his salary, since 5% of his salary is going to be applied to the pension. Okay, so he'll be bringing home 95% of his salary. And that's what we want to compute. 95%, 0.95 times of his salary, $25,000. So 25,000 times 0.95. 5 times 0, 5 times 0, 5 times 0. 5 times 5, carry the 2. 2 times 5, 10, and 2, that's 12. Then 9, indent 1, 9 times 0, 9 times 0, 9 times 0. 9 times 5, 45. Carry the 4, 2 times 9, 18, and 4, 22. 0, 0, 0, 5, 7, 3, 2. Position the decimal point. No decimal digits, plus now 2 decimal digits, so a total of 2 decimal digits. So the answer is he will be bringing home $23,750. Okay, be careful. If they ask what is his salary, how much is he contributing to his pension plan, then you would have to compute 5% of his salary. If they say how much is he taking home, $25,000 less 5% of his salary, or 95% of his salary, $23,750. And that brings us to the end of this tape.